Experiment 8 is on buffer solutions and measurement of pH. So a buffer solution is a solution that resists the change in pH when a relatively small amount of acid or base is added. So this is possible because a buffer solution contains both a conjugate acid and base pair. So for instance, if we have a buffer solution and we add a small amount of acid to it, then the basic component of the buffer will neutralize it, will neutralize the additional acid, and therefore the pH will remain relatively the same. So if we add a base to the buffer, then the acidic component, so remember I said the buffer contains both a conjugate acid and its base, so the acidic component of the buffer will neutralize the additional base. Therefore, the pH will remain the same. So let's look at a buffer that contains a weak acid HA and the sodium salt of a conjugated base NaA. The following equilibrium is then going to be involved. So if we take HA, which is the weak acid, and we add it to water, we should form A- aqueous plus H3O plus aqueous. So the equilibrium expression for this reaction is then written as the products over the reactants. So we have A- times our hydronium H3O plus over HA. So remember, Ka is the acid dissociation constant for the weak acid HA. So in order to prepare a buffer solution of a given pH, the base to acid ratio must be determined. And we can determine this using the Henderson and Hasselbalch equation, which uses the definition of pH in order to convert it into this equation. So from this equation, we'll take pKa, which is also, pKa is equal to the negative log of Ka. So if we take pKa, add it to the log of base over acid, we should get the pH. So another way which is sometimes referred to, is if we add the concentration of acid plus the concentration of the base, you should get the concentration of the buffer.